Okay, so we're gonna do my next COVID challenge here, where in order to learn about electricity, we're gonna do a potato-powered calculator. All right, so I want to do all these things with things you have around the house, right? So you probably have a calculator. You don't even have to ruin the calculator. This calculator is still usable. I'll tell you what to do with the calculator. Probably don't do a real expensive calculator. Okay, you'll need something to cut a potato in half. You'll need some paper clips. They have to be zinc paper clips. And you can use pennies, but the wire I'm using has copper in it. So you need copper and you need zinc. Potatoes, copper, zinc, a calculator, probably some tape. It doesn't have to be electrical tape. And so just so you get everything from the house, I'm gonna even show you how to get wire. Okay, so this broke the other day. My wife's it's called a hair dryer. It broke the other day. So don't use your sister's hair dryer, right? Just use something that's broken around the house if you don't have wire, right? So okay, so what I did is I need some wire, right? This was wire, just to show you. I'm just gonna basically cut some wire off of here. And don't do it while it's plugged in. If you do while it's plugged in, that would be bad. This is the first thing you learn about electricity. Don't do that, okay? So don't cut toward your thumb either, but I'm in a hurry here and I'm an expert, so I'm gonna cut toward my thumb and not hurt myself. So, all right, so I got a wire here. I need 3 pieces of wire for this. I got a wire stripper. You don't really need a wire stripper. You could do it with a regular little pocket knife or whatever type of knife. So basically you're just stripping the wire off the end here. And you could do it with a regular old pocket knife. You're just gonna score it around the outside. Trying to do this fast because I don't want to bore you to death in the video, but I also don't want to cut my thumb off. And so this does require a little bit of cutting. So, all right, so I did the same thing. Just showing you can do this stuff at home without using anything else. Okay, now what we're gonna do is the potato actually acts like a battery. A battery has zinc and copper or 2 different metals in it, and it's got an acid. This is phosphoric acid inside the potato. So if I stick a zinc in one side and I stick the copper in the other side, and I've got a voltage tester here, right? So this is on set to measure voltage. And so if I just put it to the paper clip here, and I have another penny here somewhere. Where's the other penny? Right there. And I put the penny on this side, and I touch them together. Right? I don't really get a voltage here. There's nothing going on. But if I have it in the potato and I test the penny and so I'm getting a voltage. That's more than half a volt, right? And so this one potato was only giving me about 0.75 or 0.8 volts, that's good. That's excellent. It's up to 0.9 here. So this calculator actually, if you pop it open, and there's some little screws in the back that screws out, pop it open carefully. It takes one of these batteries, and these batteries are 1.5 volts. And so in order to get 1.5 volts, I gotta have 2 potatoes. And so what I'll do is I'll take a little piece of zinc right there, and a little piece of zinc right there. And I actually don't need this potato, this is just a demo. I just need 2 of them, because 2 will be enough to run this, okay? So the hard part actually is this part. So if you can zoom in here, I've taken out the battery, and I've got a little piece of wire, and there's a positive and there's a negative side to it. So look at the battery buttons and find out which is the positive side and which is the negative side. And I use solder. That's the only thing really that's not something that you find around the home. You might be able to do this just pressing it down and using hot glue. And so just get your hot glue gun and make sure it's metal to metal, and you might be able to do it using hot glue. It's not gonna zap you. This 1.5 volts is not enough to do anything to you, so don't worry about being zapped. Now, if this thing was plugged in, right, you'd worry about being zapped by that. But this is not gonna zap you and make you in pain of any sort. Okay, so how are we gonna do this then? So I make these 2 batteries go into here. So like I said, I pop this off. These wires are going to where the positive and the negative side of the battery would normally be. And so what I'm gonna do is the positive side is gonna be the copper. And so I'm just gonna take this, I'm just gonna jam it in. Actually, I'll take my screwdriver and make a little bit bigger of a hole. And so I'm just gonna jam this in there. And so now this is literally a copper battery. That's one only though. And the other one is gonna be my battery for the my other battery, my second battery, and it's really easy to connect these. I'm just going to connect this one in the paper clip just like that, and I'm going to connect it on the other paper clip. So I can't do the paper clip paper. This is very important. You got to go zinc to copper. So that's super important. So here it's copper, and then here it's zinc to copper, and here it'll be zinc to the other end. So it goes copper, zinc, like that. That's pretty important actually. And so on this side, I'm gonna take this, I'm gonna put it in there, and I'm just gonna take my tape, and I'm gonna tape this other side. And ooh, you can see it already. So that thing right there, it doesn't work. It obviously does not go on. But as soon as I touch this, it goes. Yeah, it's going. It's going, okay. So I'm just gonna tape this. And now I can take this to my math class. And I can do all sorts of stuff with Mr. Weckler or something. And so that's the potato challenge for doing electricity. A couple things about this. This is a battery. We got a little circuit. We replaced the battery in there with some potatoes. This one potato is only about 0.8 volts. This other potato is 0.8 volts. So 0.8 plus 0.8 gives me 1.6 volts. I need at least 1.5 volts to run this calculator. Batteries always work like this, where it goes zinc to copper and zinc to copper and zinc to copper. And that's done with all the household items. If any of you guys can do this, you'll be a rock star. Take a look at the video and then see if you can do it. Okay, here's going to be a wrap-up of the video with a wiring diagram for the potato. So first let's start with the actual calculator. You can see right here I removed the battery from that small compartment. Basically you just got to snap off the back, and some of the calculators have 2 batteries. If there's 2 batteries, it'll be about 3 volts. You'll need more potatoes. This one only has 1 battery, so that 1 battery is going to be about 1.5 volts. So if we look here, this one on the side is going to be your this one right here is going to be your positive side, and it connects to this. You can see a little positive there. And then this one is going to be the negative, and if you looked underneath, you can see a negative underneath that, and I've soldered these together. This wire comes off here, and that is going to be your positive side, and this wire comes off here, and that'll be your negative. So if we look over here in the diagram, I have the same thing here. I have a positive and I have a negative, and it really is important where it goes. So the positive side is going to go to your copper, and the negative side is going to go to your zinc. So your potatoes obviously are set up like this. You have a thick copper wire, and it can't be thin. So this is a very thick copper wire. If it's not thick, you might want to use a penny to kind of add to the amount of surface area of the copper that's in the phosphoric acid. So that the battery is made by having 2 metals, in this case zinc and copper, and stuck in the potato in phosphoric acid, and that will give you about 0.75 volts, and I'm just rounding off there. A little note up here, don't let the 2 metals touch inside the potato. They're just supposed to be, the electrons are basically traveling through the phosphoric acid, and they're not supposed to actually touch each other. So the diagram works like this. Once you have it connected to your battery terminals, then your negative side is going to go to the zinc end, which means that that wire will be touched onto the first paper clip. The paper clip will be stuck inside the potato, not touching the copper wire inside. A nice thick copper wire or a penny will be jammed inside the potato next to it, maybe about a ½ inch to 1 inch away, and that will be your copper end.
And so that copper N will travel, and it has to go into a zinc. It goes from zinc to copper, and then from copper to zinc. And so that will it will be the same thing as putting your batteries the right direction. If you put your batteries in the wrong direction, then of course your item won't work. So this is putting them in the same direction. And then same thing here, another 7.75 volts. The wire goes to there, and then it comes out the other end, and the copper is connected to your positive. And so if I just zoom back out here, you'll see the whole setup with everything you need. And that's basically all there is to it. So hopefully you have a little fun with that, and give it a whirl. It's pretty amazing, but at the same time not too hard to do. So that's electricity.
Okay, good morning again. Last part. I wanted to show you a couple more things just in case you don't have a calculator to take apart. There are other things that will work if you wanted to see if you can get a potato battery to work. This one I have online is obviously a potato battery, and what I did is I cut it into three parts. You actually have to physically cut it, and then I put them back together with a rubber band after they kind of like dried off. And so that's kind of like three batteries in one. That's kind of how you would have it. If you had a battery pack. So, and obviously I use some alligator clips and stuff here. Okay, let's look at some things that you might be able to use or not be able to use if you're wondering. So, this is hilarious. This will never work. These kind of incandescent bulbs take way too much energy for two potatoes to run. I don't know how many you need, but you'd need a lot, probably hundreds of pounds of potatoes to do this. So that would be not an efficient idea to do it. And the setup is all wrong anyway. So let's get rid of that. Um, Anything that has a small battery, like the calculator batteries, should work actually. So these small clocks like that, they run on these small batteries. And so that definitely should work, no problem. An LED light, if you have an LED light or even an LED light string, but if you had an LED light string, you probably, in order to actually really get it to have enough power, enough current to run it, you're going to need a couple batteries per LED light just to make it brighter. It'll be more dim or more bright. So if you had an LED light string, you'd need a lot of potatoes. But if you just have one LED light, then it should be able to light it up if you have a couple potatoes put together. Let's see a couple other things. A small incandescent light, like a flashlight, it's still an incandescent light, and it's really hard to light these things up. Um, I wouldn't even try it. You can try it. Try it. Using a Pi to run your computer board. Um, yeah, funny. That's hilarious. It's not going to work. Plugging your iPhone directly in the potato, that may work if you stuck an extension cord through the potato, which is kind of what this person is showing. That they dug a hole in the potato and they stuck a battery inside, and so I guess they're doing some sort of potato hacks, literally speaking. But yeah, that's not what we're doing here. What we are doing is we are trying to find ways to do something that will work with a potato battery, a calculator, an LED light, or some sort of small apparatus with the small batteries would work fine. Okay, and that should do it. Hope you guys try it and have a little fun.